Okay, so in this video, we are going to solve this root locus problem. We are given with the forward transfer function g of s is equals to s squared plus 4s plus 8 divided by s squared plus 4s plus 3 multiplied by s squared plus 15s plus 56. So the first step is to identify all starting and ending points of the locus, including the infinity zeros. So if we include the infinity zeros, what that means is, in that case, poles are always going to be equals to 0. Or in fact, the number of poles is equals to number of zeros. So if there are, so in our case, it's the power of 2, it is a power of 2. So that means we total have 4 poles. And this is the power of 2 means we have 2 zeros. So because we have 2 zeros, to make this equation equal, we'll have 2 extra zeros, and these zeros will be at infinity, right? So 2 zeros at infinity, and the other 2 zeros from this equation, and 4 poles we will get from this equation, right? So let's just solve first for the starting points. So starting points of root locus are basically poles, which means we take the denominator and set it to equals to 0. Because from denominator we get the poles, as denominator of g of s must be equals to 0, and we can get the poles. Now from this equation we can get the 4 roots, and how we can get them is we put this first equation equals to 0, and we also put this equals to 0. Now we can simplify this or simply use calculator to find 2 roots from this, and we can also find 2 roots from this. So I'll simplify these. S squared plus s plus 3s plus 3 equals to 0. S plus 1 plus 3 s plus 1 equals to 0 means we have 2 roots, s plus 3, s plus 1. So these are our 2 poles. Now we can solve this one. S squared plus 7s plus 8s plus 56, s plus 7 plus 8 s plus 7 equals 0, which means s plus 8 s plus 7 equals to 0. So we total have 4 poles. So that means our starting points are P1 equals to, from here we get -1, P2 equals to -3, P3 equals -7, P4 equals -8. So hence these are our starting points. Next, we need to find the ending points. So to get the ending points, we need to put the numerator of g of s. So we need to set the numerator of g of s. The numerator of g of s equals 0, right? Now, the numerator is s squared plus 4s plus 8 equals 0. And if I set this, if I set this to equals to 0, I can solve this directly using calculator to get the answer, and we'll get 2 roots. S1, 2 is equals to -2 plus -2 iota. So from this, which means our ending points are z1 equals to -2 plus 2 iota, and z2 equals to -2 minus 2 iota. So these are our ending points. So we are done with the first part. Now we'll move on to the second part. And to see that, our second part is find all the arrival angles. So I'm going to solve the second part now, in which we need to find the arrival angle. So part B, find arrival angles. And to find arrival angles, we need to roughly plot all poles and zeros on the root locus. So we have pole at -1, we have a pole at -3. Well, let me just draw it a bit on the right side. Okay, now, so we have a pole at -1, we have a pole at -3, we have a pole at -7, and we have a pole at -8. We have two zeros, one at -2 plus 2 iota, which means somewhere here, 2 iota, and we have another zero, which is here, which means -2, -2 iota. Now the angle of arrival is basically the angle to which the locus, or the angle where the locus ends at the complex zero. So we are interested in the angle at which because the root locus starts from the poles and ends at zeros. So at this zero, one of the pole will end. So if one of the pole will end, we need to find at which angle will it end. Like, for example, this pole might come like this. So if we look at this, this means this is somewhere around 45 degrees, right? And similarly, it can also ends or ends like this. It can also go like this. Now, if I ask you the angle of this, it's some negative angle, which means -45, right? So this angle, we need to find this angle. And because the locus is basically symmetric, which means if we find this angle, we'll be able to find the angle at this point as well. Because if this is 30 degree, then this is the reciprocal. So that means it will be -30 degrees, right? Now to find these angles, we need to apply the angle criteria. And the angle criteria at this point, because we are interested at the angle of this. So what we will do is we will draw some arrows, and I name it, or let's just not just name anything. So what we will do is we will draw arrows from all poles and zeros to any one of the complex zero, whose angle of arrival we are going to find. And we know that if we find this angle, we'll be able to find this as well. And we are interested in the angles at the complex zeros. Now, if we consider, or if we want to find angle at this, we need to draw arrows from all other poles and zeros. Now we have drawn the angles. Now we will need to apply the angle criteria. And what angle criterion states is we have summation of, or we have basically, sorry, summation of zeros angle minus summation of poles angles is equals to, so summations of this minus summation of poles angle is equals to, we can write 180 degrees, right? Now, zero's angle. So how can we find the zero's angle? So we will not consider this zero because we are interested in the angle at this zero, or the angle contribution from this zero. So because we only have one zero other than this, and this is exactly at the 90 degree, so we will write 90. Plus, we want to find the angle contribution from this zero. So, and we are interested to find this, we'll write it as theta A, or because I write it, so it's basically theta arrival, right? Minus, now we need to find the pole angles. So we have one, this angle, this angle, this angle, this angle. So we basically have four angles and we'll add them all up. So I'm just writing it theta at -1. So theta from the pole -1 plus theta from the pole -3 plus theta from the pole -7 plus theta from the pole -8 equals 180 degree. Okay, now let's find theta -1. Now we can see that this angle is greater than 90 degree and it's less than 180 degree. So to find this, we need to write 180 minus tan inverse y by x. And if we see the height of this arrow is 2 and the base is from -2 to -1. So if we see the distance, the x-axis, so 2 minus 1 is 1 and the height is 2. So y by x, so that means 2 by 1. So this angle we'll get it as 116.57 degrees. Then theta -3 is equals to, again the height is 2, the x contribution is the distance between 3 and 2 because the x contribution, the x-axis of this 0 is 2, so 3 minus 2 is 1. So but in this case the angle is smaller than 90 degrees, so we'll not put this 180 for this angle. We'll write straight away tan inverse y by x, which means 2 by 1 is equals to 63.43 degrees. And theta -7, so the theta -7 means tan inverse y. So again the height is 2, but the x is not 7. In fact, it is the distance between 7 till 2. So 7 till 2 means 5 is equals to 21.8 degrees. And then theta -8 is equals to tan inverse. The height is again 2 and the x is the distance between 8 and 2. So it is 6 is equals to 18.43 degrees. Now I can put in all these values in this equation to get theta A. Okay, so let's just put the values. We have 90 plus theta A minus 116.57 plus 63.43 plus 21.8 plus 18.43 equals 360 equals 180 degrees. And if I solve this, you'll get theta A equals to 310.23 degrees. Or I can write this as in the form of negative as 360 minus 310.23 degrees. I can write it like this as well, and this means it is equals to sorry, it's not like this. Okay, so This means because I'm taking it from the negative side. So if it's 310.23, so I can add 2 pi in it. What I mean is if we have this angle, this 310 is the same thing if I add 360 in it. Whatever value I get, which is 670.23, that value and this value is the same thing. And I can subtract 360 from this and I'll get another angle, and that value and this value will be the same. So let me, instead of adding this value, I am going to subtract this value. So 310.23 minus 360, and I will get minus 49.77 degrees theta A. So this is our angle of arrival, and this is at this 0, and this 0 is minus 2 plus 2 iota, at minus 2 plus 2 iota. So if this is at minus 2 plus 2 iota, that means theta A is equals to plus 49.77 degrees at minus 2 minus 2 iota. So at another 0, the angle will be this. So these are our two angle of arrivals. And in this way, we are done with the second part of the question. Next, we need to find the breakaway break-in. So next, we need to find in part C, we need to find breakaway or break-in, if any. Okay, so let me just go to the rough plot that I draw. In part C, we need to find all breakaway, break out. Okay, now whenever you have two consecutive poles, there will always be a breakaway, not break-in. So if you are coming on the real axis, like this, and if you encounter a pole after a pole, no 0 in between, that means there will be a breakaway between these. Okay, then you get a pole and a pole. So the first thing you need to do is find the real axis segment. So you'll stand here, you'll come from this side, you encountered the first pole here, so you'll draw a dotted line here. And if I ask you a question that how many poles and zeros are to the right of this pole, including this, you need to include this one as well. So there are no other poles. So there are one pole and zeros to the right of this. So because this value is odd, which means the root locus exists here. So I'm just highlighting it. Now, we will not consider the complex poles and zeros because we are walking on the real axis. So the next pole is basically this. So I'll draw a dotted line here. And if now I ask you how many poles and zeros are to the right of this pole, so your answer should be 2. You will not include the complex poles and zeros. So because the value of 2 is even, that means root locus does not exist to the left of this pole. Left of this pole means until you encounter another pole. So root locus does not exist here. Now you'll draw a dotted line here again, and you'll ask yourself how many poles and zeros are to the right of these poles. So there are total 1, 2, 3, and this 3 value is odd, which means to the left of this pole the root locus exists. So you'll highlight it again. So root locus exists here, and again now you'll draw a dotted line here. To the right there are total 4 poles. This is even, means root locus does not exist to the left of it. So we only have 2 real segments where root locus exists, this and this. And now the breakaway concept is we will always have a breakaway if there is a pole after a pole on a real axis segment. So there is a pole after pole, pole after pole. So 2 consecutive poles, we will have a breakaway, one breakaway here, somewhere in between, means these 2 will collide and they'll go upside. Then in this pole and this pole, I will not see this because the root locus does not exist here. So I'll skip this portion, I'll go on to the next. There is a pole after pole, so there are 2 consecutive poles, so which means again there will be a breakaway here. So these 2 will collide somewhere and they'll move upside, right? So this means there are 2 breakaways, and this is the concept of the breakaway, not break in. So like I said, breakaway will occurs whenever there are 2 consecutive poles and that region is included in the real axis segment. So these 2 are also consecutive poles, but there is no breakaway in between these because the root locus does not exist here. Okay, so we will have one breakaway value between this region and one breakaway values between this region. And what breakaway means that these 2 will go towards each other side like this, and they'll move upside. These 2 collide and move upside. These 2 will go this and they'll collide and move upside. Where will they go? We'll find out. Now let's just go to find the breakaway break-in. There is no breakaway break-in basically. There is only breakaway. The concept for that is different. I'm skipping this for this problem because the focus is to solve this particular problem only in this video. So the breakaway can be found using this formula. Kg of s, h of s equals minus 1. H of s or h of s is equals to 1. H of s is basically the feedback path. So our h of s is equals to 1. There is no value in this backward path. This is our g of s and this is our k. So we'll plug in all these values down there. Okay, so we'll plug in all these values, which means k, if I plug in g of s, that means s squared plus 4s plus 8 divided by s squared plus 4s plus 3 s squared plus 15s plus 56 equals minus 1. And now we will solve for k, means it will become minus 1 s squared plus 4s plus 3 s squared plus 15s plus 56 divided by s squared plus 4s plus 8. So once we obtain the value of k, we will replace all the s with sigma. Minus 1 sigma squared plus 4 sigma plus 3 sigma squared plus 15 sigma plus 56 divided by sigma squared plus 4 sigma plus 8. Okay, now we'll take the derivative of this k with respect to sigma. We'll take the derivative of this k with respect to sigma and we'll put that to equals to 0, which basically means take the derivative here, we'll take minus 1 outside, d by d sigma, and you take the derivative of this whole thing. 15 sigma plus 56 divided by sigma square plus 4 sigma plus 8. And we put this to equals to 0. So we'll need to solve this derivative to find the sigma values, and there'll be many sigma values, but we know that the root locus exists. The values, only the values of sigma will be the breakaways that are between -1 and -3, and that are between -7 and -8. Why? Because I told you that there are two possible breakaways. One will be between here because there are two consecutive poles on the real axis segment, and one will be here. So between -1 and -3, between all other values will not be either a breakaway or break-in. Only these will be our breakaways, and they will be our breakaways, not break-ins, because they are between the two consecutive poles. I'll solve this derivative. We'll take the square of the denominator by applying the quotient rule of derivative. So we take the square, we write the denominator as is, we take the derivative of the numerator, subtraction, we take the derivative of the denominator, 2 sigma plus 4, and we write this whole thing as it is. Okay, now this whole thing will go this side, this minus thing will go this side and multiplied with 0, and they'll be removed. Now we write this whole thing again, sigma squared plus 4 sigma plus 8. Now this is again a derivation, and because this is the product rule, which means we take the derivative of this thing, we write this as is. So if we take the derivative of this thing and we write this thing as it is, sigma squared plus 15 sigma plus 56, plus we take the derivative of this thing, 2 sigma plus 15, and we write this thing as it is, plus 4 sigma plus 3. So this is basically the product rule of derivative, minus 2 sigma plus 4 sigma squared plus 4 sigma plus 3 sigma squared plus 15 sigma plus 56 equals to 0. Now if you solve this whole thing, multiply these two things, multiply these two things, add all these, multiply with this, multiply all these three things, you'll get an equation of the power of 5, and I'm writing it directly. You'll get this result, plus 31 sigma 4 plus 184 sigma 3 plus 663 sigma square plus 1568 sigma plus 1480 equals to 0. So you'll get this equation if you solve this. So usually in exams, they'll give you questions in which after solving this derivative, you'll get the power of 3, because that's what you can solve on calculator. And solving this, the power of 5 polynomials, requires a lot of effort. So they'll not give you this big polynomial. But if you have an access to MATLAB, you can solve this polynomial using MATLAB directly. So let's just solve this using the MATLAB. I wrote the code, and we already have these polynomials. We have these values, 2 sigma uh, 2 sigma 5 plus 31 sigma 4 plus 184 sigma 3, 663 sigma square, 1568 sigma plus 1480. So I wrote these as coefficient, and I find the roots. So these are the values that I get. So now I know that this value is between -7 and -8. which means this is our breakaway, and this can't be break in. This is breakaway. I gave the concept why it is breakaway. So this is breakaway. The breakaway cannot be complex, so we'll ignore these two values. Now this minus 4.22, this is neither breakaway nor break-in because this does not lie in the region of my expectation. I expect a breakaway between -7 and -8 and between -1 and -3. So this is between -1 and -3 and this is between -7 and -8, means these two are our breakaways. We'll ignore the rest of them. So let me write first the roots that we obtained from MATLAB. So we obtained sigma 1 is equals to -7.5, sigma 2 is equals to -0.95 plus -0.95 plus 3.41 iota. Sigma 3 is equals to -0.95 minus 3.4 iota. Sigma 4 equals minus 4.23 and sigma 5 equals minus 1.86. And we know that only two of the results are possible. So our breakaway are this and this. These two are our breakaways or breakaway points. That's it. Now we go back to question. We have solved three parts already. The last part is manually sketch the root locus. Now we obtained the arrival angles, we obtained the break-in and break-out. We know that there is no break-in, so we obtained the break-out. Now we need to manually sketch the root locus. For that, we need to consider two additional values. So one of the value is basically sigma, or we also call it as centroid, right? And the other angle is theta k, which is basically angle of asymptote. Why I need to find these? So I need to find these. I will always need to find these if our number of poles is not equals to number of zeros, or if there are infinity, or if there are zeros at infinity or poles at infinity. So we will need to find these two values as well. So let's just go ahead and solve these two values before I start sketching the root locus. So I'm going to solve or find these two values, after which okay, now so we need to find the centroid. This is equals to basically centroid. I call it a centroid. Okay, and centroid is equals to summation of finite poles minus summation of finite zeros divided by number of finite poles minus number of finite zeros, right? And if we sum all the poles, or the pole values are at -1, -3, -7, -8. So I sum all the poles. I'll subtract them with from zeros, which are -2 plus 2 iota, -2 minus 2 iota. So these were my zeros, divided by 4 poles and 2 zeros, which means 4 minus 2. So I'm writing it directly as 2. Now if I solve this, I'll get -7.5 as my centroid, right? This is one result. The next result is basically the angle of asymptote. Okay, so the next result is basically the angle of asymptote. So I write it as theta k is equals to 2k plus 1 into 180 divided by number of finite poles minus number of finite zeros. So this is the formula, and I get 2k plus 1, 180 divided by 4 minus 2, which is 2, right? And the shortcut is, if you have the difference between poles and zeros, your difference between poles and zeros is 2, you get two angles. One is pi by 2 and the other is minus pi by 2. If the difference is 3, you get three angles. One is plus 60, minus 60, and 180. So this is just a shortcut, but you need to find these, right? So let's just put any two values. If the difference is 2, we need to find two different values. If the difference is 3, we need to find three different values. So let's just put theta 0, k equals to 0, which means 180 by 2. And like I said, we'll get 90-degree one angle. Another, let's just put theta k equals to 1, which means 3, 180 is pi, so 3 pi by 2. And this is basically pi by 2, right? 90 is pi by 2, and this is 3 pi by 2. So I can write it as 3 pi by 2, and I can also, add 360 or subtract 360 to make it look like this. So like I said before, if I add or subtract 2 pi, so if I subtract minus 2 pi, I'll get minus pi by 2. And like I said, that if you add 2 pi, whatever angle you get, these two will be the same things. And this is the reason, if you put theta is equals to minus 1 in this equation, you'll get minus pi by 2 directly, right? So you only need to put two values, because the more values you put, you'll get the same values, but with the multiple of 2 pi. So this is basically the multiple of 2 pi. You got 3 pi by 2, but this thing and this thing is exactly same. So if you put now 2 in this equation, you'll get the same angle, which is basically the same thing as this pi by 2, right? So I'm just writing these two. I'm just writing these two for the sake of solution. I put theta equals to 0 to get pi by 2, and to make it look better, I put theta equals to minus 1 to get minus pi by 2. So my angle of asymptote are theta 0 minus 1 is equals to pi by 2 and minus pi by 2. And the angle of asymptote basically means the angles at which my poles will go. So we know that we have, I'm going to plot the root locus sketch now manually, and you'll see what root locus plot, a manual plot. So let me write all the values that I obtained. So first, in the first part, we obtained all the poles and zeros, minus 1, minus 3, minus 7, minus 8. These were my poles. We obtained zeros as minus, the starting points are poles, and these are my ending points, so minus 2 plus minus 2 iota. Then we also obtained the angle of arrival, and the angles was theta A equals to minus 49.77 at minus 2 plus 2 iota, and plus 49.77 at minus 2 iota. Then we obtain breakaway. So sigma away, breakaway is equals to, our breakaway was, we had two breakaways. One was at, I believe it was minus 7.5, and the other was at minus 1.86. So these two were breakaways. Then we obtained sigma, which was our centroid, and this value was minus 7.5. And then we also obtained theta A, theta 0, theta minus 1, which was basically our angle of asymptote, and it was plus pi by 2 and minus pi by 2. So with this data, I'm going to plot the root locus now. Firstly, I'll plot it exactly in a similar manner. I plot the rough plot before. So we have a pole at -1. We have a pole at, let me just try it again. Okay, so because the locus will be on the left side, so I'm giving more space to myself on the left side. We have a -3, we have at -7, and we have at -8. We have a 0 here, and we have a 0 here. This is 2 iota, this is -2 iota, this point is -2, right? Now, with this data, I've already used these two. I know that the root locus starts from the poles, and I also know that the root locus exists in this region. I also know that the root locus exists in this region. And I also know that whenever there are two consecutive poles, there is a breakaway. And I also know that the breakaway between these 2 points is at -1.86, -1.86. And I also know that this one will move to this side, this one will move to this side, and they will collide with each other, okay, at -1.86. And then they'll move towards the zeros because the root locus starts from the poles and ends at zeros. So these two are going to end at these zeros. And the reason is because we have two zeros at infinity. So these poles starts from this point, they'll go towards this side, this will go toward this side, and we know that the breakaway is at -7.5, at -7.5. So they'll collide with each other at -7.5, and then they'll go at which point? Now for this we need to consider the centroid. So the centroid is basically at -7.5, the same point as a breakaway, -7.5. This is our centroid. So at centroid, we need to draw a dotted line at the angles that we obtained. So let's just draw the dotted angle. I draw a 90-degree angle, and the reason for that is because these values are pi by 2 and minus pi by 2. So this is pi by 2, this is minus pi by 2. It came from this point. Now, I draw this dotted line because I say that these poles will follow infinity at pi by 2 and minus pi by 2. And the centroid will be at -7.5. So that centroid and the breakaway can be at a different point as well. So we could have a centroid here at -5 means, for example. So I'll draw the dotted line here then. But the breakaway at -7.5 means they'll collide here and they'll go here. So I'm just giving you an example so that, for example, if our centroid was here, then that means they will collide, and our breakaway was here, that means that they'll collide here and they will follow this point. So they'll go here. It's just for the sake of understanding you. So the locus follow the angle of asymptote at the centroid. The breakaway only tells where they collide, but the centroid and the theta tells where they will go. So these two will go to infinity. These two cannot go to these. Okay, they'll go there. And these two will end there. So because we already have two zeros, so these two poles will end to these two zeros. But the other two poles will end at infinity, and we also know at which angle, right? So these two will collide here, and after colliding, they will not touch this pi by 2 line and this minus pi by 2, but they will follow this line. So one will go like this, one will go like this. At this side, I basically did a little bit mistake because they collide here. So they'll go this and they'll follow this. And this one is exact opposite of this. So this one will go like this. So these two collide, these two go like this. They follow this centroid and pi by 2 minus pi by 2 lines till infinity. These two hit together at minus 1.86. They will end at, one will end at this 0, one will end at this 0. The angle at this 0 is minus 49.75. Minus 49.75 means this is minus 90. This is minus 90. So minus 49 means somewhere here. So means when these two collide, one of them will go at minus 49, this one will go at minus 49, and this one will come at 49. And 49 means if this is 90, if this is 90, then 49 means somewhere here. So this one will come like this. This is our 49.77 degrees, and this angle is minus 49.77 degrees. So we used all the values in the manual sketch of the root locus plot. So that's all with this question. We have done everything in detail. So that's it for this session. Thank you very much.